Here we're tackling the problem maximum sum circular subarray, and we're going to try and solve it with minimum complexities of O(n) time and O(1) space. This problem asks us to find the maximum sum that can be obtained from a circular subarray within an array of integers. In a circular subarray, our subarray can wrap around to the beginning of the array from the end. With this in mind, we simply need to return the maximum sum. Your options for an optimal solution here are A. Divide and conquer, B. Sliding window, C. Dynamic programming, or D. Kadane's algorithm. I'm going to pause for a couple of seconds while you make your choice. So, for those of you who recognize the most optimal solution, congratulations. And for those of you who just want to see the code, the answer here is D, Kadane's algorithm. If we look at the brute force approach, which is given by the hint button in our application, we're simply iterating through all possible circular subarrays, calculating their sums. We use the starting and end points that are possible for all subarrays, and calculate the sum for each circular subarray, keeping track of the maximum sum we've encountered so far. As you can imagine, the time complexity might be quite high here, especially if we're using nested loops. And in the absence of the much more efficient Kadane's algorithm, we would be getting a suboptimal solution. Let's take a look at what an optimal solution might be. So, here, we're using Kadane's algorithm. This utilizes the idea that the maximum subarray sum can be either the sum of a subarray or the sum of a prefix subarray and the sum of a suffix subarray. By keeping track of the maximum subarray sum ending at each index and the minimum subarray sum ending at each index, we can determine the maximum sum of a circular subarray. So, to start with, I'm going to go into the entry point of the solution and I'll jump up to these functions as we cover them. So, max subarray sum circular is our entry point, and we start by initializing n with the size of the input vector nums. After that, we're using this variable sum, and summed is a very simple function which calculates the total sum of all elements in our vector. I really hope that this is easy for you to understand. Essentially, we're just returning the total sum. After that, we're getting mn, which is calculating the minimum subarray sum within our vector using this min array function. Please note that mx is very similar. In this case, we're calculating the maximum subarray sum within our vector using maxArray. Now, we're calling these two functions, and each of these makes use of Kadane's algorithm. Starting with minArray, I'm going to explain this in a little bit more detail. So, once again, we're using n, which is the size of the vector, and result, which is int max. We're initializing result with the maximum possible integer value in our C++ solution. This will keep track of the minimum subarray sum found so far, and will eventually update it accordingly. Min so far is initialized to 0, and this variable will store the minimum subarray sum ending at the current index as we iterate through our array. In this for loop, we're iterating through each index of our vector, and line 16 is calculating the minimum subarray sum ending at the current index. It's taking the minimum value between the sum of the minimum subarray ending at the previous index which is min so far plus nums I, and the current element, which is nums I. This comparison ensures that if the sum of the previous subarray is positive, we'll be starting a new subarray from our current element. Then we're using result equals min result min so far, and this updates the result variable with the minimum subarray sum found so far. Obviously it's taking the minimum value between the current result and min so far, and eventually our function will return result, which represents the minimum subarray sum. So mm will be that minimum subarray sum. Similarly, mx works in the same way with the maxArray function. I won't go into the same detail here, but just remember that result is initialized to int min, and in this case the key lines are really here. Here we're calculating the maximum subarray sum ending at the current index with line number 27. We're taking the maximum value between the sum of the maximum subarray ending at the previous index, that's max so far plus nums I, and our current element nums I. Again, this ensures that the sum of the previous subarray, if it's negative, we'll just be starting a new subarray from whatever our current element is. We're always maximizing. Result is updated here with the maximum subarray sum found so far. We're taking the maximum value between the current result and max so far, and eventually returning the maximum subarray sum. So let's go back to our parent function. We have our sum for sum of all elements, mn, which is the minimum subarray sum in our vector, and mx, the maximum subarray sum. Line 38 is checking if sum equals mn. This condition checks if the sum of all elements is equal to the minimum subarray sum. If they're equal, it means that all elements in the array are negative, and, in this case, the maximum subarray sum would be the maximum subarray sum found using that maxArray function, which is mx. In that case, we'd be returning mx. Otherwise, we should return the maximum value between the maximum subarray sum found using the maxArray function and the difference between the sum of all elements and the minimum subarray sum, which is sum minus mn. I think that the best visual example of this case would be with example 2, given in the LeetCode test cases. As you can see, we have a circular subarray of sum 10 if we're using the last and first elements in the array. If we just used the sum here, we'd have a total of 7, which would be incorrect. Oh, excuse me. If we used mx, we would just have a total of 7. However, if we use sum, which is 7, minus the minimum subarray sum, which is -3, we'll get our correct value, which is 10. I hope that that's clear enough for you, and if it isn't, I would strongly recommend checking out the Udemy course, which I'll be explaining at the end of this video. In any case, we'll look at this one more time. You've got 4 possible methods to solve this, and of course the answer is Codain's algorithm. There are quite a few summed subarray problems which are solved using this very clever algorithm. There's a brief explanation here, but if you prefer learning by reading code, we have some code available in C++, Python, and Java. As you may notice, they all use the same underlying method, and I would strongly recommend learning the method rather than just reading and, well, regurgitating this code exactly. So finally, I'll just briefly mention this Udemy video. The Udemy course here is done by Dr. Ibrahim, and I'll always recommend that you check out his course. He offers a better technical explanation with a bit more underlying expertise than I can give you, and often more visual explanations as well. In any case, this course was invaluable for me as a learner, and I would strongly encourage any other learners to go there as well. Thank you very much for watching my video, and I hope that that's helped you with understanding this problem.